joining us. We wanted to spend some time today talking to you about a project that we are super excited about, Project Bicep, which is really focusing on the next iteration of the ARM template language. My one ask to everyone is if you can mute yourself. If you're not talking, that would be great. We're super excited because we have Brendan here to come and share some of the goals, our mission, what our views are on this project, and so Brendan leads our Azure control plane team as well as all the Kubernetes investments, and I think you guys probably are all very familiar with Brendan. So Brendan, thank you for making time today, and I'm going to hand it over to you.
Cool. Yeah, thanks everybody for joining in, and yeah, thanks. So I wanted to start with the motivations for why we undertook this project, and this isn't a project that we just sort of kicked together over the summer or anything like that. As some of you know, we've been iterating and thinking about this for quite a while, and it's because we really want to ensure that the deployment experience of people deploying resources on Azure in a declarative or infrastructure as code way is sort of best in breed, best of class, and honestly actually not even best, but enjoyable. So it's not sufficient to just be better than all of the other experiences that might be out there. It's actually something where we want to really have an experience that is awesome. And so, as we looked out at how we could achieve this, we think that simplifying the existing ARM template language, which has a great deal of usage across the fleet and across the API, was the best way to do it. There's a bunch of existing problems that lots of people can have told us about and can tell us about, that we wanted to basically improve on. Right? It's the landscape of configuration is a very complex one, and it's got a bunch of different dimensions, a bunch of different approaches. We're not necessarily out to solve all of those, but we did know that we had a language out there that a lot of people were using that was actually actively causing people pain, and so we really wanted to undertake to improve it. All right, next one, Satya. All right, so what were our goals in Bicep? And I think this is, I mentioned the first one, reducing the current pain, right? I think that's the #1 goal that we had for the project, was to really take something, this isn't sort of a clean room thing. We have a bunch of existing users and a bunch of existing deployments, and we wanted to reduce that pain. Secondly, I think we wanted to ensure there was ease of adoption, and this is both for existing users. So we wanted to make sure that existing investments in templates could be transformed, and people could take their knowledge of ARM templates and move it forward. But also we wanted to make sure that there was ease of adoption for new users as well. So like having something that wasn't too brand new, that wasn't too different than other things that are out there, and also that was similar in style and experience to ARM templates was part of the goal. We wanted to make sure that as well that you didn't have to, it wasn't a migration, and so we'll talk more about how it's not a migration, and how you can sort of take existing templates and integrate them with the new language in a little bit. We also didn't want to really build a higher level abstraction. We believe the platform and all of the server side componentry of ARM is essential, and we didn't want to sort of hide any of that. We wanted to continue to improve the platform, and also I think that part of the reason for that is that it means that if you want to continue to use JSON ARM templates, you'll continue to be able to gain all the benefits, right? So we're not going to be in a situation where there are features that are available in JSON that aren't available features that are available in Bicep that we don't think can be done in JSON as well. Although I suspect that over time most people will move away from the JSON language because of all of that pain. And then also, I think there's a real goal around modularity. Trying to, one of the pain points we have is in reusability, and that's a consistent pain point for ARM templates in general. And I think that was definitely an explicit goal here, is to improve modularity. Getting into the non-goals, I think that one of the most important ones is sort of this idea of one language to rule them all. Fundamentally, I think this space is like programming languages, and there is never going to be one language to rule them all. Even if I believe that there was one, I'm not sure that that's the right goal to go after. We really want it to be focused around customer and customer pain. Likewise, we're not really trying to necessarily build something general purpose for every solution. I think, like anything else, there's going to be different tools targeted to different solutions. So we needed to, it wasn't a goal to go out and conquer all those things. And I think the last one that it was really not a goal to invent something new, right? We're not out here to sort of redefine the configuration language space. We're not out here to, show how cool we are by building new tech. We're out here to really build useful stuff and learn from and use from models that have worked for others. So, I think that gives you a shape, hopefully, of what our approach is. So it's also important to discuss a little bit, because this is like the #1 question that came up as we were talking and putting Bicep out there. I don't know how many people are out there on Twitter, but it came up a bunch. And when I tweeted out some stuff about Bicep, people, I think it's natural for everybody to sort of assume that, like, we went off into our corner and we invented something new, and we didn't, we put our blinders on, and we didn't think about anything else. But the truth is that we actually really did, and these are the 4 major options that we explored. There was, could we just improve the existing ARM JSON language? We could have, but there's really a limit to how much you can push into JSON. It's just not intended to be a programming language. I'm gonna mute Roberto. Sorry. All right, cool. Another option that people are really interested in is this idea of a programming language. There's a bunch of different approaches, Farmer and Pulumi, and I had one called Metaparticle a while back, not for ARM, but for a different context. I think this is an incredibly interesting area. There's a lot of pros about tooling, about experience, about reaching developers. I think for what we were trying to do, and I still think that space is an interesting one. And I think that it may be something that we explore at some point. But for now, anyway, our focus is really on both ensuring consistency and sort of reducing choice. Programming languages help with tooling, but they also introduce a ton of flexibility that ultimately actually means more sort of heterogeneity of templates. And in some situations, that's a good thing, but in a lot of situations, that's a bad thing. And then also, we're really aiming this at non-dev personas who are doing IAC, but who may not be developers. And while you can use programming language tooling with programming languages, if you're not a programming languages person, none of that tooling is installed on your machine. You're not familiar with any of it. So it's actually a barrier. We looked at a PowerShell-based DSL as well. There's a lot of value there because of all the existing infrastructure similar to a programming language. In fact, PowerShell would say that they are a programming language. It's got a lot of the same pros. I think ultimately, it also comes with a bunch of baggage, in particular around Linux and open source, which is a very important part of our of Azure and Azure's growth. And so as a result, PowerShell was not something we considered it, but it's not something that we could move forward with. And then finally, we have Bicep here, and so it's got the pros that you can see we discussed about. It's obviously got the cons of it's having high tooling costs. We're going to have to do a bunch of work on tooling, and also, we are reinventing stuff, and we just have to admit that we're reinventing stuff and that we could have gotten from using other existing tools. But ultimately, we believe that con is worth all of the pros. And I apologize. I see a bunch of active chat going on. I hope people are answering questions and stuff like that for me. I can't quite talk and answer reading chat at the same time.
Yeah, we are, Brendan.
Awesome. And so, this is the choice that we came to. And a lot of this actually came from people, doing and at back when we used to go to conferences in person and actually, be in the same room. We shared out, hypothetical examples of these various approaches. And the majority of customers, existing Azure customers, preferred Bicep over all of the other options, right? And so that was really a big part of what we were guided by. And so you can see the customer findings here that we already talked our way through. Declarative over programming languages, although I would argue that you can make a programming language approach declarative, but it doesn't feel declarative to people, and so they makes people who it can be used. It's kind of like a very powerful saw. It can be used to do great things, and it can be used to chop your hand off. And so there's that risk is off-putting to some people. And Bicep really, we feel like, strikes the best balance across all of these things. So like any other compromise position, it may not make everyone, there will be camps who maybe are not ecstatic, but I think that ultimately everyone will be happier. And that's sort of the end goal. Okay, next one, Satya. All right. So this gives you an idea of how we approached the project. I think one of the most important things was that we approached it as a transpiler. Ultimately the Bicep language gets turned into an ARM template that gets shipped to Azure. So this has two really important things. One is that, it makes existing investments in templates still applicable, but also it kind of enforces on us that if we want to make improvements, those improvements happen in Azure in the server side, and those improvements come to both template users and Bicep users. And especially as we go through this transition period where Bicep is not yet production ready, it's really important that as we build new features, they're available to existing users of JSON templates, as well as the SDKs in the portal. Bicep itself is an open source project. It's out there on GitHub. We really wanted to push it out there as a unfinished raw release and an invitation to collaborate. I view this very similarly actually to Kubernetes, where we pushed out at 0.1 when we launched it. And it took a year before we were at something that we would call a 1.0 and that we would really tell people is safe for them to use in production. And across that year, we iterated with the community, and we explored things with the community. I think we're, like any other release, we're going to try and aim for a degree of stability, but not yet. So as we get towards a 0.3 release, maybe we're going to be a little bit more stable. We're going to reduce the rate at which we introduce breaking changes. And we really, really want people to come and contribute. And whether, you or, other customers outside the MVP community or anywhere else, like this is really intended to be an open dialogue. It's not going to be like, there's different styles of open source projects. Some open source projects are kind of more like, yeah, it's open for you to file issues, but we're going to write most of the code. This is really one where it's like, no, actually, we invite you to file issues, but we also very much invite you to submit PRs and to, offer up new features and everything else like that. And I think when I look at the PowerShell community, they've done a good job of inviting people into that community to not just file bugs, but actually to propose new features and actually even implement new features. All right. Next slide, please, Satya. Yes, this is the most important one of all. I know people get excited about tech and excited about new things. I would ask you and tell you, this is not something we want you out there using in production, for a couple of reasons. One is we're going to break you. I pretty much guarantee it. We are going to make some changes over the next few months that will, I don't know what they are currently, but I pretty much guarantee you that they'll break your templates. Now, all this stuff is happening client side and ultimately transforms into an ARM template. And so what breaking means may not be as horrible as like a runtime VM crashing. But still, we don't want to be saddled with the baggage of people being out in production. It will actually slow us down in the next few months, and slow us down in a negative way. So please, please come explore, please come add ideas, please play around with this. But please do not put this out into production, or at least if you're going to put it out in production, realize that the team, that if you come and ask for help, you're actually slowing us down, and you're actually making our lives, harder in some respects. So if you decide to move forward with this in the near term, it's kind of like, it's a contract, hopefully, with you that you're gonna accept that if it breaks you, you're gonna take the responsibility for figuring out how to fix yourself, and not put that burden on the team. And obviously, as we get past 0.3, 0.4, 0.5, like we're gonna get closer and closer to production capability, and we actually will solicit people to go out to production, and we will start providing more production grade support as well. But I would really ask that people treat this as an exploration, and over the next 6 to 12 months we're going to get into a place where it's something we would recommend for all production use cases. And with that, I'm going to hand it off, I think, to Alex, who's going to do a demo, and then we'll have Q&A at the end.
Brendan, I don't know what your time's like, but I'm wondering whether should we take maybe a few minutes to take any big Uber questions that people have, and then we could, if you have to adjourn, you can leave.
Sure. I mean, I'm planning on hanging around. I mean,
Okay.
I'll probably do some multitasking, but I'm going to hang around for the duration. But I'm happy to take questions now. I mean, it might make more sense to take a few questions now, but I don't know.
Sure. Brian or Alex, are there any big questions that we want maybe Brendan to answer? I think one that came up is, I think people are excited and want to blog about it. And so any guidance around that? And I think Brendan's Uber message is to tone the expectations. And so I think that is one, but I don't know, Brendan's is others that you want to add to that.
Yeah, I mean, my feeling of this is like, hey, we put it out on GitHub and it's a public URL. So like, ultimately we don't have any control over what you do, and I wouldn't try and exert any control over what you do. But I would request, I would request that you carry the warnings forward around, that this is intended to be a community project and a community exploration. This isn't hey, this is the brand new thing that you should start using in prod now, right? Because as I said, ultimately that the more support burden the team takes on in the first few months, the less proactive feature work and the longer the delay is towards getting to production. So I just, I would just ask that you keep that in mind. Ultimately, as I said, like, go nuts if you wanna go for it. But do keep in mind that we're not trying. This is supposed to be sort of a low key, soft launch kind of thing, rather than a go big, it's production grade tomorrow kind of thing.
And Brendan, to follow up, I think the question that we're being asked is, when do we think we'll be production grade, or customers can start to use it with customers?
I mean, I think it's I think the answer to that is a little bit unknown. I think 6 to 12 months. In some ways, it depends on how fast the language stabilizes, right? And because ultimately, like, as I said, this is like, it's a client-side tool. And so the two bad things that could happen, one is that the template that it generates could be wrong. Like, it could just delete a VM or something like that because it messed up. And then two is that the language could change so that existing Bicep files stop working. And so, like, for the first one, you just need mileage, basically. And so, I would expect that 3 months-ish of mileage is probably enough to get that mileage once the language stabilizes. And then for the other one, we just have to get to stabilized language. And so it's going to depend a little bit on how quickly that development happens and how much discussion there is around the language spec and how many changes we take. But I wouldn't expect anything faster than 6 months. And maybe, but I doubt it. So somewhere in the sort of build, a little bit before build timeframe. And it could stretch out till next summer. But I hope it's a little faster than that. That's sort of setting expectations. But again, it's going to be a graduated series, right? I mean, like even, like at a 0.5, it's safer to take it to production than at an 0.1, and at an 0.8, it's probably pretty safe, especially. But again, you want to, you want to just be aware of the ways in which problems can be introduced.
I think the other question that came up was, what are the differences between this and the Terraform language? And I think maybe Alex showing the demo will crystallize some of that, and we can talk through some of those nuanced differences and the transparent abstraction that we talk about.
Yeah, I think that'd be great. I think if we want to talk about language details, that's a great thing to do after the demo.
Yeah, and Satya, I was just going to say too, it's like there's a lot of questions that are flying by. If people have a question that's not answered, just raise your hand, and we can open up the mic and go that way too.
Yeah. Similarly, feel free to, if we don't get to it or you have a thought later on that you didn't think of during this call, feel free to just file issues on GitHub, right? If you want to have discussions, feel free to just file issues on GitHub.
Alex, do you want to start the demo?
Cool, yeah. So everyone can see my screen, right?
Yep. If you want to minimize the video thing on the bottom right, that'll be good. Yep.
Then I can't see you, Satya. So this is the landing page for the repo. README's pretty thorough. Goes over the basics and some of the improvements that we've made. Known limitations are an important one to look over. These are point-in-time limitations. These are not forever limitations, so there's a lot of issues associated with them, and we're working on some of them now. And then we did add an FAQ kind of based on the response and the questions we were getting asked frequently. So this one's another one to take a look at. But I'm going to start by going to the docs directory and jumping to the installing page. So if this is your first time on the repo and you haven't yet had a chance to play with Bicep, there's two components that you need to install. There's one really that you need to install, which is the Bicep CLI. And this is what actually transpiles your Bicep file into an ARM template. And then we have a VS Code extension, which I'll be working with today, syntax highlighting, and we'll add a lot of improvements. There's some validation there, but there's a lot more coming. So you can follow these instructions to install the CLI and to install the VS Code extension. It should be pretty seamless, but obviously if you have any issues, please do open an issue. From here, we will jump to the tutorial. And basically what I'm going to do with this demo today is walk through the tutorial and try to call out how the kind of language is put together and how it works. And it shows off most of the features that are available now. And then with any time we have remaining, I'll try to go through some of the specs of some of the future looking things like modules, so you get an idea of how those fit into the larger picture. So we'll start by just creating a new file. Oops, we'll do it over here. Main.bicep. And we'll see the Bicep language server start, so it recognizes the Bicep language. And I will compile this blank file just to show what that looks like. So I'll do bicep build main.bicep, and that generates the equivalent ARM template. So this is just a skeleton ARM template. It throws in all the different top-level keywords of an ARM template, including functions, outputs, whatever. Not all of these are required, but this is a functional ARM template. So no boilerplate or anything like that in a Bicep file. So we'll start by adding a resource type, and I'm going to actually split my screen. I'm down to one monitor. I'm on a new computer, so I have to split my screen. And I'm just going to type through everything so you get an idea of how everything works. Let me collapse this. So resource is a top-level keyword. And you'll notice I actually get some snippets here to get you started. So I'll start with this one, and it puts in what needs to be here for a resource declaration. I have tab stops in here, so I'll walk through these. The first tab stop is on the identifier, or what we sometimes call the symbolic name. And this is separate and distinct from the actual name of the resource that's going to get created in Azure. That's this resource name. So I will just call this STG for storage, and then I can use the tab stops to fill in the type of the resource. And you'll notice this is a combination of the resource provider, the resource type, and the API version for that resource type, which these were separate properties in the ARM template, but collectively they actually represent the type of the resource and dictate what properties are available to you for that resource type. So we're going to do Microsoft .storage/storage accounts, and then the API version is 2019-06-01. And when we say we are a transparent abstraction and we're exposing the platform to you kind of as is, this is really what we mean, which is that all resource types, all API versions are available on day one. There's nothing that we need to do to onboard this new resource type into Azure. You won't necessarily get all the validation that you could potentially get. That's something that we do need to do. But to actually make the resource work in Bicep in an ARM template, there's nothing that we need to do to enable that. So I will give the resource a name. I do equals here, which there's an issue of whether there should be an equal sign. I think that is a fair discussion to have. And then there's a bracket, and then I have all my object properties here. So I have unique, storage, 001, and we'll mess with this later. My location is East US, and then my property, or I actually don't need properties here. I have kind of storage, and then I have SKU, name, standard, LRS. So I can now just rerun Bicep builds, and it'll regenerate my JSON file with my storage account. So this kind of works as expected. Type and API version, which are on the one-liner declaration of the resource, are broken out into the relevant properties in the ARM template. We are going to introduce like a bicep watch command, so I can just do bicep watch once, and then as I save, it'll just continuously generate the JSON. That's a great issue. If you want to submit a PR, that's a good first issue to work on. And now we will start adding parameters. So we support in this 0.1 release the main kind of high-level keywords of an ARM template: parameters, variables, resources, and outputs, and we will add to that over time. So for parameter, we've shortened parameter to param. The structure is the same structure as a resource. It's keyword, in this case param, identifier, in this case location, and then the type, which are your basic types like string and int and that sort of stuff. And then I can actually set a default value in one line. So this is more of a quality of life, cleanliness improvement. Declaring a parameter with a default value is relatively verbose. Now you can do that with a one-liner statement. If I need to, I can introduce all the parameter modifiers that I'm used to. We've moved secure string into a parameter modifier, so I can do secure true. I can still do default values. We've shortened that to just default, so I can say East US. And then we still have things like allowed values, so it's just allowed now. And I can say East US, I can say West US. If I wanted to do min length or max length or all the other modifiers that you're used to, they're all supported. So we'll just leave that as is, and then we'll also parameterize the name, and then we can just move that out. So now where we've had the string here, we'll just reference the parameter directly. And so you're no longer having to do brackets, parameters, name, something like that to reference that parameter. Any value can be an expression. You don't need the bracket syntax to start using expressions. And then another important point is that this is a shared global namespace for these keywords, these identifiers rather. So I cannot have a variable. So I can't have a variable called name, which I gave a location, because there's a conflict now. And this is so that we don't have to have something like param.name or var.name. It does mean that you can't have those things anymore, but ultimately we believe that that trade-off is worth it for kind of cleanliness and readability. If I hover over these, I will know that these are a parameter. And I know Stan had mentioned if we can have syntax highlighting to differentiate, I think that's a good idea. So we can triage that as well. Any key questions that I should stop and take? Satya, Brian, Brendan, Marcin, Anthony?
Alex, Sam asked about putting parameters in a different file. You want to touch on that a little bit about the definition and the values?
Yeah, so I think Sam might be asking about, but Sam, correct me if I'm wrong, just separating it out into a separate file, just literally copying and pasting this into a separate file in the same directory, a la Terraform. Is that right? Sorry, I'm not looking at the chat.
Yeah, Sam, are you asking about like the definitions or the values for the parameters?
Yeah, so I guess both is the question. So from a Terraform world, obviously you can stick anything you want in a separate file. It just munges them all together at the end in terms of the actual template, and then the actual values in their own file or coming from the outside again. So I guess both is my answer.
Yeah, so on the first one of being able to just break things out into separate files and basically just concatenate them together at build time, that's something that we are considering, but we haven't closed on. So if people have strong opinions on that, that's worthy of I think there is an issue for it, but if people want to comment in the chat how they feel about that, that's a great point of feedback and discussion. I go back and forth personally on whether or not that's helpful or harder to deal with, but it's definitely something that we're considering. The parameter values file, so the parameters JSON that you're used to today from ARM templates, we haven't touched that yet. So you'll still generate your ARM template, give it a parameters file if you want, same parameters file that you're already used to. We will likely bicepify that at some point, but we haven't started working on that yet.
Okay, so effectively the value you've got in here at the minute would be the equivalent to the old default value.
Yeah, so we can actually, let's regen this.
Yeah, and think of this, the definitions here as kind of like the contract or the interface for the template. So it makes sense to have those with a template, but yeah, then it is just default values beyond that.
Yeah, that makes sense.
And let's also replace our location. And so we have parameters set up. We will move on to variables and outputs. So I can have my storage SKU as a variable. We automatically determine types for variables, so you don't need to specify a type. And then I can just replace that with storage SKU. And then lastly, I have an output, same output structure, or same structure as the other keywords. So I have storage ID string. And this is where we have some kind of new functionality, which I'm personally a big fan of. So we have our output of a storage ID. I want to output the storage resource ID for whatever reason. I have keyword, identifier, type, just like a parameter, basically. And then I am assigning it a value. In this case, it's storage.id. And this is where that symbolic name is really useful, and you'll see it become more useful through the other tutorials. This is the equivalent of writing resource ID, Microsoft.storage/storage accounts, parameters, parens name. So this is really just a quality of life improvement, readability improvement, authoring improvement to be able to pull properties from here. I could also pull the name property. So if I had like a unique string here that was being calculated, I could just pull the name pretty easily. I can pull the API version. I can also pull properties that I would get through the reference function, which I'm going to demo a little bit later. So I can do like storage.properties.primary endpoints.blob, for example. Which I think is in this tutorial. We can build this, and we get the storage resource ID calculated correctly. This is what was in the comment earlier. So you can see, I mean, even for, this is 15 lines, there's quite a bit of verbosity that we've gotten rid of. I think maybe a misconception is that, yes, we are going to reduce the lines of code to an extent, but most of the lines of code is actually from the resource declarations, which we're not doing anything dramatic there to abstract those things away. So the lines of code will be less, but not dramatically less. What is dramatically less is the number of characters that you're typing. So we've seen, more or less like a 30 to 40% reduction in the actual characters, and that's all the ARM template noise going away and just leaving exactly what is essential for declaring resources in these Bicep files. So we'll move on to 2, and we'll just briefly touch on 2, which is about deploying. The net on deploying a Bicep file is we're not doing anything to help you deploy a Bicep file. So you will build your ARM template, and then you will use the standard deployment CLIs or REST APIs or SDKs or portal, whatever you want to use to deploy that template file. And if you want to supply parameters, you can do that on the command line if you'd like, or you could use a local parameters file or a remote parameters file. An important note just to touch on for 0.1 is that by default, we're assuming that you're deploying to resource group scopes. All that really means is that we are generating a resource group scoped schema at the top of the file. And when we introduce resource validation, which is not too far away, we will assume it's a resource group scoped template, but we will obviously have the ability to target any scope and do cross-scope deployments and all that sort of good stuff. We're just not quite there yet. If you want to deploy non-resource group resources, you can still do that. You just will need to change the schema if you want to get validation in the tooling. But if you want to just deploy it, we actually don't even check that this schema matches the resources. So you can just deploy it as is. Okay, next we will move on to using expressions. So we're already using expressions when we reference a parameter name or a variable name like we've already done. This storage.id reference is an expression. Any property value, I can use an expression for it. So where else can I use, or how else can I use expressions? Any ARM template function that exists today can be used in Bicep. So I can still use the resource ID function if I need to call it explicitly for a resource that's not declared in the Bicep file. I can do things like resource group.location. I can use all the string manipulation functions. Basically anything that you can use, you can still use in Bicep. And this is where that point that Brendan made, that we're not creating an entirely new language, or really just revising the existing language. That's kind of what we mean, is that the runtime is still the same, the functionality is still the same. It's just, in some sense, a new coat of paint on how you author. So we're going to replace a few things with some functions. So we're going to replace the location with resource group.location. And then we are, sorry. Welcome to my home. My dog barks at everybody. So we set the location to the resource group location, and then we are going to replace the name with a unique string. And I think I'm actually gonna, well, let me do this in the right order. So we're gonna replace the name with the unique string, because that unique string was almost definitely not unique. So I'm gonna do unique string and then resource group .id. And you see, obviously, I'm getting syntax highlighting. It understands that these are a function. It doesn't really understand anything more about what this function returns, but that is all coming in due time. And so now we have a unique string. But even in that unique string, this is just going to return a bunch of garbled letters and numbers. I actually want to prefix this with something. And this is where I would do something like, and this still works, I can do concat Alex, and then get my other parens to match. This is the way we're used to doing string concatenation in ARM templates. This is one of the most commonly used functions in ARM templates, and it leads to quite a bit of verbosity in matching parentheses and kind of reading what this string is actually going to output. If you like string concat, you can still use that, but now we actually support string interpolation. So if you haven't used string interpolation, it basically lets you use expressions inside of strings with this $bracket syntax. If you've used it in C# or JavaScript or PowerShell, a lot of languages support it. It's pretty convenient. So we now support that in Bicep. So we will actually replace our storage account name with a variable. And we will do string interpolation for this. So I think I replaced my name parameter with a name prefix parameter. So I could set this to whatever I want. So I'll just call this stg. And then for my storage account name, I'm going to use that name prefix. And then I'm going to concatenate it with the unique string. So I'll just type that out again. And then I'll replace this whole thing with storage account name. Okay, let's keep going. We did introduce the ternary operator. So this is the equivalent of the if function in ARM templates, which again can get pretty nasty to read if you have a complex condition statement. So let's add another parameter. And we'll just call this global redundancy. And it's a Boolean, and we'll default it to true. And notice I've done something here. This is totally personal preference. I put the parameter right above the storage account. I could have put it in the same list as all my other parameters, and it's equally as valid. So you can be a little more free form and have a little bit more personal style into how you want to declare parameters, variables, and outputs. So I have this parameter called global redundancy. I'm going to use this to determine what SKU I want to use. Redundancy. Redundancy. And then I just do a question mark. So this is my condition, true or false. And then if it's true, it's going to be standard GRS. And if it's false, it's going to be standard LRS. So these are a little bit of a cleaner way of doing the if then else syntax for property values specifically. This is a simple Boolean expression. I could make this more complicated. I could have other Booleans, and I can use like the and statement. I can do and is, what's today? Thursday. I could have a Boolean for is Thursday. Obviously, this doesn't exist yet. But where I had to otherwise use the and function and the or function and the not function, I can do kind of more standard Boolean expressions that I'm used to from other languages. Okay, second to last tutorial, but I think the last one that we're going to spend some time talking about, which is using the symbolic resource name in more places. So we've already used it once with this storage ID, and that's a replacement for the resource ID property. I can get these other what we call compile time properties like ID, name, API version, and type. So if I'm doing something like the list keys function, I need to get the API version, and so I can just do stg.api version in that case. So we've already seen that with the storage ID. I mentioned earlier, because our storage name is unique, let me get rid of this. Oops. I can also output the storage computed storage name, also a string, and then I can just do stg.name. We can compile quickly because we've done a bunch of stuff and get an idea of what this looks like. My storage SKU is unused, so that's why I'm getting a warning there, but otherwise this looks mostly as I would expect it to. You'll see on line 21 for string concatenation, we're using the format function. This is just a little bit easier for us to work with in the IL. Functionally, it does the same thing as the concat function. And then I have my condition statement here, and then I have my outputs. So it knew that the storage account name was a variable, so it was able to pass that through the right way. I can also use the symbolic name to retrieve runtime properties. So this is things that I would get with the reference function, basically. So I can get the storage endpoint is the next output I'm going to add. So I'll do output blob endpoint, also a string, and then stg.properties.primary endpoints.blob. We do actually, today in ARM tools, we only know about the put schemas of what properties are valid on put. We also want to do the same for get properties. So we want to be able to give you IntelliSense on stg dot, properties dot, and then pull in properties that are specific to that resource type and API version. And that'll all come from the swaggers, the resource type swaggers. So this is the equivalent of writing the reference function. So I could have done reference. In this case, it would have been variables, storage, name. I forgot the name of that variable. And then I could have done dot properties dot primary endpoints dot blob. So again, syntactic sugar, quality of life improvement, hopefully make these easier to write, easier to read. We can compile this and get a look at how it calculates the reference function. Here's my blob endpoint. Here's my reference function. It does know whether it should add the full parameter or argument to the reference function. And because it's not adding full, it just knows to do primary endpoints.blob. You shouldn't have to worry about that in practice. And then here's a fun one. We can also automatically calculate depends on if there's an explicit reference to the symbolic name. So I'm going to copy and paste here just the beginning of this to save me a little bit. And equals. So I'm going to create a blob container within this storage account, which is a child resource. This works for child resources. This also works for any other kind of resource dependencies. So the only thing I need to specify here is the name. And for the name, I'm going to concatenate the storage name because it's a child resource. So I'm going to actually use that symbolic name to do stg.name. And then I append that with /default/logs. And now it understands that this actually needs to happen first. There is an explicit reference to this thing existing. So if I do bicep builds here, I'll see my container and it knows to add that dependency for me automatically. If there's not an explicit reference to this symbolic name, I can actually add depends on here, and I can reference the storage symbolic name here as well. So if there aren't explicit references, if you're using something like a deployment script or something like that, you would need to do an explicit reference in those cases. And there's an issue open to warn you if you're adding kind of unnecessary depends on, because we already know about it. So hopefully we'll be able to teach people when to use depends on and when they don't actually need it. That is the last kind of meaningful tutorial on some of the syntax. If you need to, the 5th tutorial is about how do you convert kind of any ARM template, provided it meets some of these requirements. Like we don't support copy loops yet. We don't support conditions on resources yet. We don't really support nested deployments yet. So if it's a relatively simple ARM template, or if it just has a lot of resources, you can convert that into a Bicep file. So we walk through exactly how you kind of think through that and do that. But I think once you play with Bicep, you'll realize that the process is pretty straightforward. We are planning like a decompiler of sorts to take you from ARM code into Bicep code. It'll be, a best effort thing. We won't emit perfect code. Ultimately, it's machine generated code. So you will want to go in there and kind of refactor things and stuff like that. When you do refactor, we already support kind of some helpful refactoring things in the VS Code extension. Because basically we've built the language service in the right way, and credit to Marcin and Anthony who are on the call who built all of this. You can get some great functionality like rename symbol right out of the box. So if I wanted to call this Alex, I could do that and it would get all the replacements correct. So I can do a bunch of refactoring like that really quite easily. We support find all references, go to reference, all that sort of stuff. It's really just playing with what VS Code provides us, given that the language service is operating in a way that it expects it to operate.
Alex,
Okay.
Sorry, the two questions that popped, I think one is when is loops coming in and other advanced functions. So I think that was one question. The other question is, I think a lot of customers are forced to use the SDK or CLI because they're things that are not supported in templates. And so it's a little bit about what are we doing to, make sure that everything is modeled in the control plane, as well as what's our extensibility story.
Yeah, so for the first one, we want to have loops and conditions in like either the 0.2 or 0.3 release. We'd like to get it done before the end of the year, basically. So if I go to docs and spec, you can see everything in here is basically syntax that we've either already implemented or closed on, and we think it's what we're going to implement. Everything's kind of always subject to change, but you can see here things like loops, and resource conditions are in the resources spec. So you get an idea of what these things look like. Modules is the other one that's interesting. So hopefully by the end of the year is the short answer to that question. On having to do things with the CLI or PowerShell or what have you, a couple things. One is there are a bunch of things that should be in the control plane that are not, that should be ARM APIs that are not. And there's kind of a continuous effort to bring more of those things into the control plane. And part of our hope with Bicep is that we kind of bring some new life and new energy into ARM templates and describing your resources declaratively. And that should encourage teams to do the right thing to make sure that the Bicep experience or the ARM template experience is as good as it can be. So Stan and I were going back and forth on an issue about key vault secrets and being able to do a list secret function. For that, the key vault needs a post function to grab the secret. That's one that we need to put more energy into to make sure that you can do that in ARM templates. On things that are kind of data plane that should be data plane or have nothing to do with Azure. Our goal with Bicep is to deliver kind of first-class end-to-end experiences for deploying applications and infrastructure to Azure. Often that means that there's like a last mile thing, like a pre-action or a post-action that you need to do, a la create a Kubernetes deployment, create a user in a database, whatever it is. There will be places where we want to make that possible in Bicep, and we will have kind of an extensibility point for some of those things. We haven't figured out exactly what that's going to look like yet, but we know we want to do it. What we will not do is kind of like a broad provider model where we expect to be kind of an equivalent of Terraform in the sense that you can just hit any provider on any cloud and what have you. That's really not our focus or our goal for this effort.
The other question is, I think we should spend some time to talk about modules. I think it's a key piece of our story. And so I don't know if we can show an example and how we think about it.
Yeah. So I can go through this spec a little bit. To declare a module, basically any Bicep file is a valid module. So it can choose to expose parameters or not. It can choose to expose outputs or not. And that will ultimately determine how the module is consumed when it's instantiated. So in this case, I have a parameter with the account name, which does not have a default value, and then a set of database names which do have a default value. This is also showing some of the looping syntax that we have. So when I actually have to instantiate this module, this is going to be required when I define it. So when I consume it, this is the usage, we will have a new module keyword. It'll follow a similar structure to the other keywords, module keyword, identifier, and then type, which I'll put up in air quotes, I guess. The type is a pointer to the module file. This could be a local file. This could be a remote module. You can imagine us having like a central set of modules that Microsoft maintains and manages and puts their stamp on. So all of those things are things that we think we're going to do. We'll start out with local modules and then expand from there. So you can have a modules directory in your repo and just point to something here. And then you'll see that I have to fill out the account name and give it a value. Otherwise, the module will fail to instantiate. And we'll provide tooling in VS Code to know what parameters the module is expecting, what are defaulted, what are not defaulted. And then on the other end, when I have declared my module and I want to reference it, I can use that same symbolic name or identifier, get the outputs, and get whatever outputs were made available to me. So this is really the contract of what a module exposes, the parameters it takes as inputs, and then the outputs that it defines. We intentionally don't want to let you change values of things in the module that are not declared as a parameter, because at that point, we can't really help you to know if that module is going to succeed or fail, because you're messing with things that were not intended to be messed with. So that's the basic overview of modules. A module can contain one resource. It could contain 500 resources. There's really no limit into what you want to do. And then when we compile this, we're going to compile this as a nested template, an inline nested template with that property that you may have seen called expression evaluation options set to inner. All that means is that it's going to deploy the way that you expect it to. We can just inline it all and send it to ARM in a single API call. That makes our lives a lot easier. So that's how we're going to compile it. It is possible, and something that we are considering, to compile it into separate files into more of a linked template structure. So if that's what you're used to and that's what you like and you want to stage the files, we can output it that way as well. So that might be like a compile time option.
Thanks, Alex. I thought we'll open the mic up. One thing is I would love to hear your guys' feedback on, do you guys feel this is a good investment in the next revision of the ARM template language? Love to hear your feedback on that. And then if you can raise your hand up and if you want to come to the mic and ask a question, we'd love to take questions for the next 2 to 3 minutes. I know Brendan probably has to run as well. Go ahead, Tijani. Tijani, if you're talking, we can't hear you, unfortunately. All right, we'll come back to you, Mike.
Yeah, I was kind of wondering if in the you've got the Bicep to build to create the ARM templates. Is there any thought around having a Bicep run to do the deployment and push it out there, maybe run things in the right order, basically take away that PowerShell deploy?
Yeah, great question. So we might add a Bicep deploy command to the Bicep CLI, but really what we are shooting for is to integrate this into the PowerShell deployment and CLI deployment commandlets, such that I can say AZ deployment create, and then point it to a file that has the .bicep file extension, and then we'll just compile it for you and deploy it on your behalf. So you don't need to, if you don't want to, be aware that there's a JSON file involved.
Okay, cool.
And then Alex, what if I just want to compile the file and not deploy it? Is that going to be a separate command, or will PowerShell CLI have that option?
I imagine we'll expose it in PowerShell and CLI as well, as some kind of flag or command that you set. Ultimately, it will be calling the Bicep CLI, so we should be able to expose all that through. But good question.
Tijani?
Yes, can you hear me now?
Yes, we can hear you.
Okay, great. I just wanted to say that it seems a great solution. We used to work with the ARM template for our customers, and we design our solution iteratively. So we build our ARM template iteratively to fit the solution we are building, and over the time the JSON files gets bigger and bigger, and it's harder and harder to come back to it and add some new stuff or modify existing stuff. So with the Bicep, it seems very easier and very natural to do this. I have a question for you, if that makes sense. Let's say I compiled my Bicep files, and now I have the JSON template. Okay, if I make a modification to the JSON file, can I have this modification back to the Bicep file?
things would get challenging there. I mean, you could decompile, so we're going to have like a decompilation tool to go from ARM to Bicep, but we're not going to be aware of what the Bicep file that you already wrote looks like. So we would ultimately change your symbol names and all sorts of things because we would just be auto-generating a lot of that stuff. There will be, it's a bit of a hard question to answer because we don't have the decompiler yet, but we want to have the ARM JSON be like a one-to-one representation of Bicep so that you should be able to, in 90% of cases, go back and forth without any changes. But it will depend on what you're changing and exactly how you're changing it. The recommendation would be to always make your changes in Bicep files. You shouldn't be trying to make changes in the JSON.
Okay, but sometimes people are more familiar with JSON since they worked a longer time with JSON files. So my guess is that it would be possible to have, like, say, convert this JSON file to this Bicep file.
Yeah, let's put a hold on that one. When we have the decompiler, we can start to play with what works well and what doesn't. But it will be, the answer will always be, it depends, basically.
Okay, thank you.
Ryan?
Johnny, I think the general idea behind that is we don't want you to go and mess with the JSON. It should just be an intermediate language the platform cares about. You shouldn't need to care about it. And if you find yourself in a situation where you're dropping down to the JSON, please file an issue so that we can go resolve it and make that scenario better.
Okay, great. So my question was just because I anticipate right now that our customers who are more familiar with JSON file because they worked with it for a longer time, well, once they will generate the JSON files from the Bicep file, they will probably want to work or fine-tune the JSON file, and they probably will want to have that fine-tuning back to the Bicep file. But okay, I understand the point, and it makes perfect sense.
I think the thing that may be helpful, and you guys can help us get a feel for this, is when you're starting to write Bicep, you do have this muscle memory thing of like, I know how to do this in the JSON, but I don't know how to do it in Bicep. And the ternary operator is a really good example. It's like maybe we need to come up with a kind of a FAQ or a common set of things that you're going to do that are a little bit different in Bicep, and just have that cheat sheet available so people, again, they don't need to drop back into the JSON to get an answer for things.
Oh, this is a great idea. Thank you.
Ryan?
Hey, Ryan.
Yeah, so I just wanted to say this looks really great. I think for the people that this is really targeted to, which are those who are new to doing things with infrastructure as code for Azure, will be, they'll look at this and go, this is a much easier way of getting there than ARM templates really are. For those of us that are seasoned with ARM templates, it's going to be good because it means a lot less writing, which is always a good thing, right? The point that I think people mentioned about deploying Bicep files as opposed to deploying ARM files, I think actually what you want to do is liaise with the CLI team and the PowerShell team and just expand the deployment mechanism so it will look for either a JSON file or a Bicep file and just do that automatically. It doesn't care what the actual end content is, so that essentially what I can do within my pipelines would be to run new AZ deployment, template file, and point it to .bicep or .json, and allow the tool to do the work as opposed to it being something else elsewhere, because that would reduce a lot of headaches in local testing and also long-term environment management, because nobody wants to go and amend all of their templates and their pipelines that they use.
Yeah, that is exactly the plan. That's what we're shooting for. So you should be able to reference a .bicep file and then do what if with the commandlet, deploy with the commandlet, whatever you need to do. And it's a bit like the AZCLI and PowerShell can call kubectl. It's a bit like that relationship where ultimately they're just calling that binary, but they've made that a little bit more opaque for you.
And just into Simon's point that he's just raised with building AZ template, Yeah, that would be great. I would like definitely to see a decompiler come out for basically pointing to a repository and go, let's decompile all of these ARM templates into a singular Bicep template or a series of linked Bicep templates. Because I've got one repository where I think there's 30 or 40 linked templates, which are various levels of nested linked templates for doing different deployments of resources. So it'd be good to get that functionality in there in V1. And you know me, I'll be more than happy to help get you along that path with it.
Awesome. Yeah, we will try to get the decompiler done sooner rather than later, because it's going to be a thing that we need to refine over time. So hopefully 0.2, potentially 0.3 will have some of that stuff out.
Cool. I think, we can adjourn for today. Thanks to everyone for joining. We can't do this journey without you. And so my big ask is to please try it out, give us feedback. The reason why we actually made this public and we made it public really early, is we wanted to actually be this as a collaborative effort with the community, right? We didn't want to be, hey, let's Microsoft go and invent something and then throw it over the fence and take it or leave it type of thing. And so really wanted this to be a collaborative effort. We are in the alpha stage of this process, so do cut us some slack. We're going to make breaking changes. We're going to get things wrong, but we really want to do this with you guys. And so my big ask is, contribute to the GitHub repo, at a minimum, open an issue, right? If you have a feedback, or at least open an issue, try it out. And, we want to have a conversation with you guys. And so my big favor is, do collaborate with us, and we want to go down this journey with you guys. And so thank you from me and the rest of the team. We really appreciate everything you guys have done for us. And Alex, Brian, myself, Anhel, and the rest of the team, we actually did interview a bunch of you guys in Jan timeframe about this project. And so I wanted to thank you guys for meeting with us, giving us feedback, and your feedback is what's actually this new language is because of the feedback you guys gave us. So thank you for spending those hours of time giving us your feedback. I really appreciate it, and looking forward to partnering with you guys on this. Thanks, everybody. Have a good day.
Thanks, everyone.
Thanks all.
Thank you.